Good morning, everyone. Good morning. Hope all is well. Hope everyone's doing all right. We got a few people still trying to connect, so let's give them a chance. Yes, 10.1 and 10.2 are the last sections. All right. Oh, wow, this stuff's so big. All right, so looking at 10.2, I'm going to walk through some hypothesis testing. All right. So last night, I sent you guys these steps right here, hypothesis testing steps. So you have your initial conditions that allow you to be able to do your hypothesis testing. And they may test, and I'm going to pull up the assignment in a second just to see. I know in my other class, but that's 155, they actually ask you, is n times p not times 1 minus p not greater than or equal to 10? So, and that's pretty much just multiplying it. Let me look real quick at this. Don't see it in this one. Yes, okay, yep. So we're going to walk through a problem that asks you that. But that's just multiplying n, which is your sample size, times the population proportion, times 1 minus that number. And if it's greater than or equal to 10, then that means that we can continue to go ahead into our steps. Step 1 is what we talked about last class with establishing what test we're going to do, whether it's two-tailed, left-tailed, right-tailed, by establishing your null and alternative hypothesis. Your significance level will be chosen for you in these problems, and we'll walk through the rest of it. You have a classical approach and a p-value approach, and yep, we'll look at both. I'm going to show you how this problem is presented to you. I already had it up. Give me 1 second. Okay, so Math Lab is having issues right now. Hold on 1 second. It's Nigel. Hold on 1 second. I was trying to get in the Math Lab. Normally what I do is I pull up the problem and show you how they actually give it to you. Try it one more time. Okay. All right, cool. So I was wondering why my stuff wasn't up, but they have a message on Math Lab saying they having technical issues. Okay, well, that's good. At least I wrote down most of the problem. Okay, so yes, this is what we're gonna write. So number 3, and I like to confirm my stuff just to make sure, but evidently this is number 3 from 10.2. And in this case, they gave us this, and they give us this. And they say perform the test using the p-value approach. All right, so this is given. This is the stuff that's given. Now, there are some problems that actually have word problems attached to it. So there are further problems down, but in this case, they actually give you all of it. All right. So when you look at your hypothesis testing, this number right here is P naught, your population proportion. All right. And so that's why I have that right there is 0.7. And then P hat is always going to be X over N. And that's your sample proportion. And we talked about all these terms before, but just giving you a reminder. All right. So depending on the problem, they may give you P hat or they may give you X and N and expect you to know how to calculate P hat. All right. Everybody okay? So now we need to come up here and calculate the test statistic. That's going to allow us to go to the z-score chart and establish our p-value and all the good stuff like that. So notice p hat was 0.6 with 3 repeated. So you notice when I wrote down here, I wrote 0.6 and then I went out at least 4 more 3s just to give you the most accurate answer possible. So I did 0.633333 minus 0.70. Now it would not be to your benefit to just write 0.63. You do need to take it out some decimal places. So like I said, your answer can be as accurate as possible. Remember we mentioned before, going out 4 or 5 decimal places should be safe. All right. So here, if you have a calculator that's capable, you just plug it in right here. Make sure you use parentheses properly. So you have your numerator and then what's in your denominator, you know, divide it out. So if you ever need help with your calculator, don't know necessarily how to use your calculator, always make sure you get with me, whether it be during office hours or set up a time. We really wouldn't do that during class time because everybody has specific stuff, So now you attention just on one person when the whole class looking at you. So that would be more so office hour or separate time to talk about your specific calculator. But yep, so we're walking this all through. That's all this is. And then I will end up with negative 1.78. Now don't forget it's a z-score. So you always round to 2 decimal places. So that's why it's negative 1.78. All right, is everybody okay? All right, so go to the chart. And just a reminder of our chart and how we use it. And that email sent you a z-score chart as well. What is going on with my stuff? There we go. So we're looking at negative 1.78. So that's 0.0375. All right, so now we can say that this is our p-value, but what would determine that is just like in chapter 7 when we were dealing with z-scores, keywords, key phrases, or key symbols. Remember, we're dealing with left tail, so we're talking about less than. Remember, the chart always gives you less than, so this is our p-value. But that's because it's less than. If it was greater than, then we would be subtracting that value from 1. Just that same thought process. And then there's something different for two-tailed. We'll talk about that in a second. But is everybody okay with the p-value before we come to our conclusion? All right, so now go back to your hypothesis testing. Yeah, where it go? Yeah, that's classical. So your p-value, if p-value is less than alpha, reject the null hypothesis. So now we look at our p-value compared to alpha, which was given once again. Since the p-value is greater than alpha, we do not reject the null hypothesis. If it was less than alpha, we would reject it, but it's greater than, so we will not reject it. All right, questions. All right, can we scroll up to the next one? So this one's very similar, except it's two-tailed. Hold on one second. Want to see. See, I want to pull up one that had a word problem. Because I didn't write the word problem. Because if I'm not mistaken, number 6 was a word problem, but can't do that. Anyway, maybe I'll do it next class once math lab get up. Okay, so number 4. And so in this one, if I'm not mistaken, they give you this again. So in all of them, they give them to you. It's just that in some of them, they'll give them to you in word problem form. So in other words, they would say the sample taken was 500 and certain amount of people did, what they say 390 people did such and such. You know what I mean? So that would be N and X. And they would say the population, the population came in at 81%, blah, 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 blah. So that 81% as a decimal is 0.81. So it would just be in word problem form. All of this would still be given, but in these first couple of problems, it's given to you just like this. But as you get further in the assignment, they give it to you in word problem form, and so you have to pull the information from the word problem. So maybe I'll when we do reviews, anybody asks, we can walk through it again if you need it. But like I said, I can't pull Math Lab up; they have technical difficulties. So. All right, so P is equal to 0.81 as our null hypothesis, and the alternative hypothesis is not equal to 0.81, so that means it's going to be two-tailed. N is equal to 500, X equal to 390, and alpha is 0.1. So they ask us, does this scenario meet that initial condition, N times P naught times 1 minus P naught greater than or equal to 10? And so all you would do is throw that in the calculator. So I did here. And that gave me 76.95, which is greater than or equal to 10. So we're good to go. right? So P hat is going to be 390 over that 500, X over N, which is 0.78. And then once you have that, you can go ahead and plug it into your test statistic formula. So anybody holding on to black? So plugging all that in ends up giving us negative 1.71. All right. So can we go to the chart? Let me see if I put the directions under here real quick. I didn't. Okay. So we got negative 1.71. And if you go to the chart, we'll get 0.0436. Now remember, it's two-tailed. And so this would be the diagram if we had to put a diagram on it. Negative 1.71 and positive 1.71. All right. So we have these two pieces. We know 0.0436 is over here, but because it's symmetric, remember how this thing works, it's symmetric about the mean. That means it's 0.4036 over here as well. So for two-tailed test, you're going to multiply the p-value by 2. And that'll give us 0.0872. All right, questions? Everybody good? Now we're about to compare the p-value to alpha. Kind of already wrote it right here. I must have ran out of room for what I was doing. So our alpha was 0.1. My p-value is 0.0872. So since the p-value is less than alpha, we will reject the null hypothesis. All right. Also, let me see something real quick. There was something trying to see if I want to Let me do this. Why did it jump that big? All right, so everybody still holding on to this before I go down? All right, so I did want to point this out. Our test statistic was negative, so it wasn't that big a deal. We just took, whatever value we got from our Z-score chart, multiplied it by 2. But if the test statistic is positive, you would take the negative representation of Z0 or the test statistic and get the chart value and then multiply it by 2. Because remember, both of these are what you're going to use. But if you were to get the positive one, it's going to give you, everything over here. Remember, we want just this piece. So if the test statistic is positive, in other words, Z0 is your test statistic. If that's positive, take the negative representation of it. So in other words, if we had 1.32, take negative 1.32 and get that chart value, then multiply that chart value by 2. And this is only for two-tailed. Notice it says two-tailed down here. So those 2 conditions, test statistic positive, and you're doing two-tailed. Two-tailed is the only test when you can multiply it by 2 because it's the only one that has 2 tails. Mm-hmm. And we're still copying. Okay. So, oh, somebody said something. Oh, my bad. Sorry. There you go. Oh, no, you good. You good. There's no rush. All right. So let's look at last scenario. And so let me see if there are any words to it. Yeah. So this is the last scenario. You remember we only had 3 scenarios: less than, not equal to, greater than. all of them the same process. It's just that at the end you either have less than, greater than, or not equal to consider. So try these out and see if you have any problems with them. And then we have until how many days of class we have? One, two. We have all next week. We have the rest of this week, all next week. To ask whatever questions you want to have. And I believe I told you guys the 25th as well. I think I told you your final exam was on the 27th. Okay, it's right here. Yep, final exam. So we have three days of class time that you can ask whatever questions you want to ask. Let's see. You say you want to have the final next Wednesday? So we have three class periods where you guys can come and ask questions, office hours, or basically have, from here to here to make sure you guys are good. All right. So let's look at, why am I stuck getting larger? Okay, last one for today. Once again, we have our null and alternative hypothesis stated. So P equal to 0.94, P is greater than 0.94. So there was, in this one, was a word problem. And what dictated that we use the greater than symbol was them saying more than. Remember that goes back to like I said, chapter 7, when, if they say less than, using the less than symbol, more than or greater than, using the greater than symbol. If they say different, they want to test to see if it's different, then we would use not equal to, because that's just, going to mean, that means it's not going to be equal to, or it's going to be different. All right. So like I said, in the word problem, they give you all the information. It's just that they give it to you in word problem form, and you have to pick out each piece of information. So do our little test as far as our initial condition, see if that's going to be greater than or equal to 10. And we have 12.69 when we do our multiplication. So that works out for us. In the problem, they said 214 of the 225 was whatever the characteristic was. So that means 214 is X and 225 is our N. That's our people that we surveyed or whatever, the sample size. And so to find P hat, you would do X over N. And so that's what's going on right here. All right. So now we have to find our test statistic, P hat minus P naught over the square root of P naught times 1 minus P naught over N. Once again, we have here, 1 is being repeated. So you see how I did my calculation, 0.95, and then just wrote 4 or 5 ones after that. So our z-score ends up being, or test statistic ends up being 0.70. All right. So now this one looks like it's set up for the classical approach instead of the p-value approach. See, I want to confirm, man. MATLAB messed me up today. And then we'll just roll with it. Okay. So critical value, if we're going to use the critical value approach, not critical value, the classical approach, we need to get our critical value from the z-score chart. And so, because notice that's what the classical approach is right here. P-value, which was the first two, is right here. So you go to your z-score chart, go all the way down to the bottom, and notice right here, C gives you hypothesis testing critical values. So if the level of significance is 0.1, 0.05, or 0.01, left tail, right tail, two tail, it'll tell you what the level of significance, what your critical values will be. So we were looking at right tail, I believe. Yep, greater than. So we're looking at right tail. And our significance level is 0.1. So we're looking at that 1.27. All right. So this is for the classical approach. If they asked you to do the classical approach. So that's why I sent you the z-score chart, again, just in case you misplaced it. On the second page, right here in this bottom corner, is where you can find your critical values. And you will just find them according to your significance level and what test you're doing. So once again, our significance level is 0.1, and we're looking at right tail. So we're going to look at that 0.128. So that's what I have right here. Okay, I have somebody saying they can't hear me. Can anybody else hear me? If you do a thumbs up or yes, I can hear you or something so I can make sure it's not me.
I can hear you.
Okay, thanks. Appreciate it. So thank you. Let me at least let her know. Okay, she just came back in. Okay, so let's go back here. So now, if you go back to your hypothesis testing, for the classical approach, you're going to compare your test statistic to your critical value. And so we are right here for right tail. If your test statistic is greater than your critical value, you reject the null hypothesis. All right. So if you follow these steps, you can always reference them. They'll let you know what to do after you've done your proper calculations. So do not reject the null hypothesis because test statistic was less than our critical value. Well, our critical value was less than, hold on, did I write my symbolism wrong? T alpha, right. Test statistic was less than my critical value. Yep. I was thinking about something from the p-value. Yeah. But once again, if your test statistic was greater than your critical value, then you would have rejected the null hypothesis. All right, questions. All right, so that's all three tests. What we can do is, if you want to go through some more, you can always come back on Monday. I'm pretty sure MATLAB will be back up then, and I can pull a problem from MATLAB and walk through some more. But I think this is good enough to almost definitely get your feet wet, get you on the right path of trying these things out. Make sure you do try them out, see if you are going to get stuck, so we can make sure you're good going into our next big thing. So let's go back to our scheduling, make sure we okay with what's going on. We just finished out 10-1 and 10-2, so that's it as far as new material is concerned. So we have all of next week and then the Monday after for you guys to come to class and ask whatever questions you want to ask. Our final exam will be a 2-hour block starting at our class starts at 9, starting at 9, so from 9 to 11, you'll have that amount of time to take your test. And we mentioned the second attempt will be available to you, but everybody has to do the first attempt in order to qualify for that second attempt. And then really the second attempt is only going to be beneficial to you if you score less than a 70, if you score less than a C. And then from there, you have until May 1st, midnight, to submit all of your work. Get everything in. All right. Any questions on anything before we close out today?
Yeah, I have a question.
Sure.
I was sick on Monday and I missed Monday's class. When are you posting the Monday lecture?
Best case scenario, I'll get it done today. If not, tomorrow.
Okay.
Yep, tomorrow. So I'll try to get it done today, though. Especially when I have requests like that, then I try to go and get them in. Normally, I don't do them until like Friday because that's when my real official free day is to get that stuff done. But when somebody requests it, I try to get it in the day of, since there is a need. You know what I mean?
Okay. Thank you.
In fact, let me put it on my list before I forget. Always got to create a to-do list throughout the week. See somebody else. Give me 1 second. All right, so at the finals, can we still go back and improve? You have until May 1st, 11:59, May 1st, to do whatever it is you want to do. So, yep. Have until May 1st. Once it roll over to May 2nd, the due date, that'll be it. Then I have to get grades in. All right. Anything else? Anybody else? And going back to 10.1, 10.1 was all laying out the foundation. We didn't do any calculation. I mean, not saying it's not necessary. I'm just giving you a heads up as to what we did in 10.1. Just laying out the foundation, setting us up for 10.2. We did all the calculation today. There's a class survey. There's a normal survey for every class that I don't send out, that the school sends out, if that's what you're talking about. All right. Anything else? Anybody else before we close? Yep. It'll come out shortly. I don't send it out. Yep. Very good. Okay. So you guys have a great weekend. Be safe. I will be back. I will be here each one of these days. If you don't have to come, if you don't have any questions, I'm not going to force you to come to class and listen to somebody else's questions. The next day that I have to see you is this day. But I will be here all 3 days. If nobody shows up, I'll do the 15-minute thing. If nobody shows, then I'll go ahead and I'll do something else. But just to let you know how those 3 days are going to be, accounted for. It's not, not looking for anybody to come if you don't want to come. It's all about you and what you need. And if you need, any help. All right. So the next day that I have to see you will be April 27th, which is your final exam day. All right. So you guys have a good one. Be safe, and I will see you either next class or when I see you. Right. All right. You take care.
Thank you.
Thank you. You have a good one. All right. Thanks. You do the same.